Hi, good morning, everyone. Thank you very much for joining us here for being carried out about the webinar. So, unfortunately, I'm very sorry for the inconvenience for Mr. Kelvin. Will surely be here with us soon as possible. Um, Indeed, we're here to discuss about how my developed software, or the software that I developed, will analyze CCSDS packets on satellites and detect anomalies on satellites. And once again, I have to thank you a lot for joining here with me. So I think we'll head over to the main topic we have to discuss here today, which is how Orbisect will analyze CCSDS packets on satellites and detect anomalies. And what is CCSDS packet? The meaning of CCSDS packet is a consultative committee for space data system. Indeed, Orbisect's approach to satellite threat detection combines protocol level it combines protocol levels analysis with machine learning to provide real-time defense capabilities. I think we'll break it step by step for us to understand it more better and for clarification. And we go beyond step one. This step one, it says the consultative committee for space data system packet injection. This is what we have to look at in this step one. And we said this Orbisect listening to telemetry feeds either from a live SDR signal, that is software defined radio signal, or either from network source or a G-entry based simulation, that is a graphic network simulation. And these streams, after all this that is listened to, it form what we call a streams. And these streams follow the CCSDS, that is Consultative Committee for Space Data System protocol. This Consultative Committee for Space Data Systems protocol is the global standard used by space agencies. And each incoming CCSDS packet that is the Consultative Committee for Data Space for Space Data System packet contains a header, and this contains a header. This header are APID, like application process ID, and we have sequence count, and we have a flags and data payload. For that, this is a little about the CCSDS packet injections, and we head over to step 2. We'll look at the packet decoding, how the packet is decoding, how the Orbisect is decoding the packets. We said is using a tool like Escape. Orbisect use a tool like Escape to decode the CCSDS primary header, and those headers are a version, type, APID, that is application process ID, and sequence, length, and others. It also extracts relevant fields like a voltage, temperature, positions, and velocity. For all these informations it gathered, it can passes all this information above to the internal database and dictation pipeline. Are we understanding? I hope we are getting it very well. So we head over to step 3. This step 3 is anomaly detection, but before that, at least we have to show a live how the Orbisect decode packets in real time. So let's assume that we have a 2 terminal here for the practical session. Let's see how it decodes, the Orbisect decodes the packets. We have the first terminal and the second terminal here. And what we have to do here, we use, ideally, we make it in ideal that the first terminal is the one that feeds, and the second terminal here is the one that receives the feed. That is, this is the second terminal. This second terminal is the one that is receiving a code. That is, it's decoding. You understand? So for that, we said in this first terminal, we send the feeds to the Orbisect. We send the feed to the Orbisect side. We have and now we send the feeds. Sorry, we have to go to the directory. We activate the directory of Orbisect. Then we send the feeds to the Orbisect. We say CCSDS simulator. Now, as you can see, in the first terminal is moving, is sending a feed to the Orbisect. Now we move forward to the second terminal, which is the one that is receiving the feed. We go for the directory. Then we say this one is in a clean way. We have PESA, CCSDS PESA, and we see how it receives the feed instantly. So now, as you can see, it takes some little time to pick whether it is valid, to pick the valid IP sequence and others, as you can see. So the Orbisect now is receiving an IP valid and it flags as invalid too, as you can observe in the second terminal. So that is, this first terminal gives the feed, and the second terminal receives the feed, for which it flags as invalid and valid. IP sequence and length also, as you can see in the second terminal. So what we can do next, after all this that is receiving, then we check the socket pipeline, the web socket pipeline, to see the dashboard, to see whether how it flags anomalies on the CCSDS packet. So as you can see, this is the dashboard. We are going to head over to the dashboard. So we can check the CCSDS packet. We have like 96 anomalies detected correctly. We check the result. We have the total packet of 169, valid packet as 145, and invalid as 24, continuously more often. So we check, each satellite have its own API, that is application process ID. So we check for the application process ID. You can see the recent packet anomalies, the timestamp. Today is we have a 1st of August 2025. And check we come for the word API, that is the application process ID. As you can see, we have all of the OXFF pattern. You check each of every pattern over here. We have the sequences. The sequences contain 24, 24, 24 in each API. And we have the anomaly type. You can see the type over here. We have all patterns and the repeating patterns and diversity, a 1 unique byte too, a low entropy 2. So the same count is over here. We have 24, 24, 24, 24 as same count. And when you set your eyes, it changes. We look at it, it changes. It can change in time. So we head over, we change to see whether it can change the API, the application process ID. We give it time to see whether it can change. So one interesting thing is that whenever, if there is no any simulation, if there is no any attack or hijacking or spoofing, this CCSDS monitor will never flag as anomalies is detected. It will keep waiting, the dashboard will keep waiting for any jamming attack. That's the interesting thing. So we set our eyes whether it can change, the API will change. Let's refresh the dashboard to see whether the API will change. It takes a little bit time to display. Are you with me? Sequence it keep move, as you can see, it's now displaying correctly. So this is what it detects today, so this is how it decodes the packets. You can see, I think it's very clear. Then we go back to our normal business, which is we head over to step 4. So in this step 4, what we are going to discuss here is how anomaly detection logic is. So the Orbisect uses what do you call it? It uses a hybrid detection engine, which is a rule-based checks. It uses a rule-based checks. You know, so it flags value outside what do we call it? Outside the known threshold, e.g., like temperature greater than 100 degrees Celsius. Whenever it flags value outside the known, when it flags outside the known threshold, like temperature, if it is greater than 100 degrees Celsius, the alert will flag on invalid sequence or packet loss. You know, and then the anomaly detection logic, it raised assured as in machine learning, which is machine learning models. In machine learning models, we have it's been trained on historical satellite telemetry. That is, we have a density-based anomaly, a cloud race. So all this is being trained in historical satellite telemetry. It also uses what do you call it? Algorithm like isolation forest, that is DB scan. You know, to assign a severity. It will also assign a severity. It marks a score. It gives them a score, which is from 0 to 1 to each event. You know, so what we are going to see here, we check the anomaly, how it flags. So as you can see, we have something like this. As you can see, we have something like this in this temperature. You can check the positions, you can check the altitude, the velocity, the voltage, and the temperature. So observe the temperature here. You know, we have 20.7 degrees Celsius. Whenever it rises beyond expectation, that is, whenever it's going beyond our expectations, that is, the temperature will go high, very high, so for which the anomaly will be detected in sequence and orders. So what we have to check now, we go through the anomalies, the tab, anomaly tab. We can see that the anomaly tab is flagging. As you can see, it's flagging. Can you see? We have this is the timestamp of the anomaly. We have a voltage 7.39 voltage outside range. That is, it gives you outside range 26.0430 of the volt. It is outside range instantly. So you check for the anomaly here. This is where it detects the anomaly for us to view each and every stage, each and every decodes. Okay, now we have like 820 anomaly in our dashboard. So we check. So this is the analysis. We have like anomaly severity. It gives them in score. This is the severity, a level. As you can see, we're in level 3, a 2 from 0 to 3.5. So this is the analysis here together with us. You can check the timestamp, the anomaly type here. It is unknown, the voltage out of range. So indeed, what we are we're able to ask here is how the Orbisect can mitigate, or how, when the anomaly is detected, how is it going to mitigate? No, of course the Orbisect is being trained. Okay, the Orbisect is being trained. It can detect and avoid any sequences. You know, it shows the result for you to extract. You can even download the result here. You can see the export data here. You can export the data to get your further analysis. So for which there is no any mitigation strategy for this Orbisect. What you can do when it detects, it can either for the spoofing or jamming attack, the Orbisect automatically will avoid any anomaly or any other APID, which is the application process ID, that is anomaly. It's not in the same sequence with your satellite. You know, I hope you are getting me well. So I think we will not get much time about this lecture. I'm very sorry indeed for the inconvenience about the Mr. Kelvin that will join us. Unfortunately, I don't know why. I don't know whether he's busy or not, but I want to assure you that maybe in our next webinar he will surely join us by God's grace. But the great news is that the message has been delivered. What we have to learn here, we have acquired a lot, and I'll give you time for the audience to ask some questions, whether if there is anything they want to be highlighted. We'll see what we can do. Any questions before we proceed? I think we don't have to waste much of our time here. We have a lot to do. So any questions? Any questions? Seems there is no questions. So thank you very much for joining us today. I wish if I can see you in our next class. Thank you very much. Bye.